I made an operating system. For the last year or so, I've been working away on developing the operating system or the monitor for the TEC-1G. This is called Mon 3, the version 3 of the monitor, and it's finally complete. And when I started playing with the tech, I had no idea what a monitor was. I think it stemmed back from the Apple II days where you got that screen with the little asterisks. They called that the monitor, where you can have access to the computer's memory. And like with this monitor, it gives you the ability to access the memory of the computer and also the hardware as well. So I'll put it into the ROM slot, turn the computer on. So initially it has that sound, the loading sound and graphical screen here. That's telling you that it's done a hard reset, resetting all the monitor memory locations and data ready to go. Now I don't know if you've actually figured out what that tune was, but I'll give you a little hint. Won't you take me to It's actually from a song called Funky Town by Lips Inc. or Pseudo Echo. Now I've already done a video on the TEC-1G when it was launched and the initial monitor, but I've made some changes. So let's have a look at some of those changes and some of the improvements. So we'll get into the data entry mode by pressing address. And here I've made some changes. There was 5 bits across, but people don't complain about the 5 bits. It was, we normally read in 4 bits. And because now I've got some space on the right hand side here, I've added 3 extra components. So the first one is DA or AD. So it just gives you an indication, are you in address or data mode? And also when I'm changing the address and data mode, you can see here the dots move. So this is currently in data mode, where I can, when I type now, it will update the data in that location. And if I press address again, and it's the address mode, now I'm updating the address location, so the dots have moved across. The second thing I've updated here is the ASCII character code of, whatever's at that current byte. Well, currently it's 04, which is not much, so I've put in like 45, you've got E, 46, you've got F. So that's a good way to, if you are looking at data that's actually text-based, you can actually read it directly from the screen instead of converting the ASCII codes. And the last one is this weird N0. Now, what this actually means is when I'm keying in a byte, I need to key in 2 numbers. And so this is telling me I haven't keyed in anything in the current location. So if I type in 5, okay, so it updates the first location here, or the first nibble. And also the dot has changed. So the dot here is now on the first dot instead of 2 dots showing. That means I've got one more key to go to update the number. So if I do 5 and 7, you can see the dots move to the second location. I'm on nibble 2. And what this means is that if I type in another number, it will automatically move to the next address location and update that value. So if I do 9, you can see it's moved to the next location and I'm on nibble 1, 9A, nibble 2. If you made a mistake, let's say you don't want to update to the next memory location, you can just press address and address again, and that will reset to nibble 0. So now I can overwrite 9A with 89 or whatever I want. And you've still got the real-time disassembler line happening here, which is also very useful when keying in codes to make sure that whatever you're keying in is correct. I'm not going to go through all the existing features that I've already demonstrated, but I'll show you some of the new features that I've added to the latest monitor. The first one here is quick links. So if I do function 0, I can set certain addresses to quickly jump to those addresses. So in order to do that, first you need to go to the address. So I'll press address and let's do 5000. Do function 0 and I'll press 2. Okay, and then I do address, let's say 200, and do function 0 and do 3. Now if I do function 0, I can see I've saved address 400, 500 and 200, and I can easily just quickly jump to those locations by pressing function 1, 2 or 3. So function 1, 4, function 2, function 3. That's a quick links. Another feature that I've added is a useful tool to wipe the memory and to put no ops or 00 or nops, no instructions, no instruction into any part of the RAM. So if I do function 8, I can now fill addresses with the no ops or 00. That means the CPU understands that as just ignore, and I can set the to and from address. So I can put in 500 and I can put in 5FFF and press go. Now this is going to wipe the memory in that location, so just press C to confirm, and that's done. So if I do function 2, I go to 500 and I can see now they're all 000s in those locations. And if I go to 600, I can see now that it's still all 00s until 6000. So a couple of the existing features are smart copy, so function C, and block copy, function B. Now block copy, what that will do is just copy a chunk of memory from one location to the other location. And that could be good, like to back it up. So you back it up into a certain particular address, but let's say you want to retrieve it back to the same location. Function A, function A, which actually restores from backup. So to demonstrate this restore and backup, I'm just going to add two numbers together, adding A and B register together, and then I'll move that program from two different locations. So let's create the program, 3E, so load the register A with 04, and 06, load the register B with, I don't know, 09, and then we'll say add A and B together, so that's 80, which is add A and B, and I want to see that on the screen, so I'll just set a breakpoint, so I'll just break at that location. So let's give that a run. So we go back to 4000, press go, and I can see here the register A is OD, which is 4 plus 9, which is 13, or OD in hex. So that's working fine. So exit out of that. Now if I want to back that up, that little program, I do function B, and I type in the address, which was 4000, and the end address was, what is the end address? 40045. I can see here, up ahead, so I do backup 4004005. And I'm going to copy it to location, let's say 2000, and go. So that's now copied. So if I do function 2, and I can see the program function 3, I move to 2000, and I can see my little program there, and I can run it again, and there it is, it's OD. But what if you want to copy that back to 4000 location? So if I go to 400, which is here, I'll just wipe out some bit of memory there, do function A to restore. It's actually pre-filled the start and end address and destination because it knew where the previous backup was. So I just need to do function A and press go, and it'll copy it back. And there's the program. And run it. Yep, OD. Perfect. So one way to communicate to this computer via an external source is via the serial connection here. On production boards, it sits over this side here. Now the current baud rate is 4800, and that's set up as default. Now you can actually change the baud rate. To do that, you go to the menu, function address, go to settings, and you can set the baud rate. And these are the baud rates available for bit banging, and the fastest you can go on this computer is 14400, which is okay, but if you really want to go fast, you really need a dedicated serial chip like the Z80 SIO. On top of being an awesome Z80 trainer where you can enter code, create programs, do fancy things, the monitor also supports a few add-on cards, and I'm going to go through all the add-on cards that the monitor supports. Have you been dreaming of that electronic project and want to make it a reality? Just like my ultimate expansion board for the TEC-1F. Well, head over to PCBWay to make your dreams come true. PCBWay are the leading printed circuit board manufacturer. They make high-quality multi-layer boards with a 24-hour production time. Just enter the board dimensions and upload your Gerber file, and that's it. Once posted, A neat box will arrive with your well-packed goodies. Just look at the quality of this board. They also do PC board assembly, CNC machining, and 3D printing. You can even order user project boards directly from their website. For $5 off your first order, click on the link below. PCB Way, prototype the easy way. So here is the Matrix keyboard. It's got two versions of it. It's got the old tactile switch keyboard here, or the more fancier Cherry key or Gateron key keyboard. In terms of price wise, this is a lot more expensive. Being a bigger board, this is a lot more affordable, but hard on the fingers. It just uses a IDC connector to plug into the side of the TEC, and it can be used. So I'm just going to plug that in now. Alright, so it's plugged into this port down here on the left hand side, bottom left hand corner. In order to get this to work on monitor 3, you need to flick one of the dip switches over here, number 3, the third dip switch, flick that on. Now, this is the beta board. The dip switch is under the LCD for me. On the production board, it's much more easily accessible. So I'll place the LCD back on top and turn the computer on. Alright, now because I've flicked the switch, these switches, this keypad doesn't do anything apart from apart from reset. So now I can control the TEC by using the arrow keys and all the other similar keys for the hex pad. So if I want to go into data entry mode, press escape and I can type away. So, 3E. And with this particular keyboard here, there's also backing lights as well. So if I turn the lights on, if I can get the switch, there it is. I've indicated where there's two settings. There's for all lights on all the keys, or just the keys that map to the hex pad over here. So these are the hex pad lights I can see. So 3E, 01, D3, 02, D3, oops, got to go minus, D3, 01, 7, 6, escape. To reset here, you press both Alt keys together at the same time to reset and go. And there you go, little character on the screen. In order to get the fully operation of the keypad working, you need to access the APIs of the Monitor 3, and you can access that. And later on, I'll show you some programs that do access the full keypad. Alright, so this is the real-time clock board, or the RTC board. It sits on top of the general purpose I/O sockets, which sits over here, and its main purpose is to keep a clock. It uses the DS1302 chip that maintains the clock, and most of the circuitry is basically just to keep this chip running. But one special thing it has here is non-volatile RAM, and with the battery connected, you can also save up to 31 bytes of data. The tech guys have called this particular RAM PRAM or PRAM, programmable RAM or permanent RAM. And so having that programmable RAM, you can now save some of the options on the TEC permanently onto this chip. So when the computer is powered down and turned on again, you're not going to lose some of your settings. So I'll just put this on the board now. It sits over here. So you don't notice much difference here, but in the menu here, we have in the settings, if you go to settings, you can go to configure RTC and reset RTC and PRAM. So if I go to configure RTC, you can see the current settings there. So it's got the current time and the date as well. Now those times and dates can be just set by pressing various keys on this hex pad here, hours, minutes, seconds, weekday, day, month, year. You can also view the PRAM, so if I press 8, I can view the PRAM and all 31 bytes worth. The first 16 bytes are actually reserved for Monitor 3, and they store various values, which I'll show shortly. And then the rest are available to be used for your own use. You can go down as well, press escape there. Now if you do have one of these boards, I have made some modifications to the way the data is stored, so you'll do need to do a reset when using the latest monitor. But let's have a look at some of those PRAM variables being used on the 1G. So I go to data entry mode. Now we did the quick links before, so if I do function 0, you can see there's already the quick link stored, so the quick links here will save on PRAM. Also, if I do a parameter like copy or block copy, it also saves the start and end address of the last block copy and destination. It will also save the baud rate that you've set, and two other features. If we go to settings and right down here to settings, the toggle key beep or the toggle address increment. So this automatically increments the address when the first byte is filled or the two nibbles are keyed in. So those two values can also be permanently saved. So if I toggle the key beep off, if I turn the computer off and turn it on again, yep, still no key beep, and everything like the PRAM is set up the same, like the quick links, everything's working well. So that's the RTC board. So the next two boards are really game changers for this tech. It's the ability to store data on a hard drive or on a disk or on some sort of solid state memory. And the two boards that you can use is this PATA board, which is the parallel ATA board. There's a lot of logic here, mostly because of trying to convert 8 bits into 16 bits, because this disk here, or the compact flash card, actually communicates in 16 bits. And this one sits on top of the tech deck connector here. And I have demoed this board before, so you can have a look at a previous video. But I've also integrated to be able to read data from the disk using an existing board, the SD board, or the micro SD board here. And this board sits on top of the general purpose I/O sockets, and it can stack on top of the RTC here. It's much more simpler because it uses SPI communication, so less chips involved and just serial communication to the card. So popping that on top, and I'll turn this on. So in order to use the card, it needs to be formatted into the FAT32, FAT32 file system, be on the first partition, and use MBR partition scheme. Once you've done that, you can copy the files across to the root directory. So to access this card, you just go to Drive Access, which is on the main menu, and hit Go. It gives you some options here to catalog the disk and load and save the session. So if I do catalog, it's now reading the disk, and here are all the files. So no more need for communicating with the serial port here, or having any sort of permanent RAM or programmable ROM installed. You can now load as many files as you want onto this disk. So let's just pick a program that we'll do LCD runner. So that loads up. It only takes a few seconds. If it's a hex file, it automatically interprets the hex file, Intel hex file, and loads it into the appropriate memory location. So go back to the data entry mode, and there we go, 4000, got some code there, press run. And here's a tech runner game. So press go. And this little game here, you got to jump the blocks, and timing is all very important. You don't want to hit any of the blocks flying towards you, and if you don't time it properly, which I am doing now, you die. So let's hit the top there, and I'm dead. So there's one game loaded up on using the SD card. Another feature it has is to save all of RAM onto the disk, and in order to do that, you need a particular file called mydata.tech. It will read that, and it will save the current session. One way to get access to the catalog is, a quick way to get access to the catalog is by doing function F. And you can see here, there is a file called mydata.tech. In order to save the session and restore the session, I can go back to the Drive Access menu and do Save Session and Load Session. So if I do Save Session, now this is saving all RAM and the extended RAM. So over here, I've got in the expansion socket here, I've got some more RAM here, 16Ks more RAM. So it will save the current RAM and the extension RAM, or the expansion RAM. And you can see here it's ticking over. And when it gets to address, I think just before C000, it will then switch to the expansion RAM and save that as well. It's a bit slow, especially with the serial communication going on here. I mean, it's not super fast, but look, have the ability to save the session and then a few days later come back and then restore exactly where you were before. It's like a game changer. So now it's saving all the RAM. It's in the expansion mode. You can see here this LED is flicked on, saying I'm now looking at the extended RAM on the expansion socket here, or the second half of the RAM chip, and that's done. And to load the session, you just to recover that same session, you just go to load session and it'll load it. Now in this case here, it'll give you confirm just in case, because you are going to wipe the data. So this is going to be a game changer for the TEC. No more cables anymore. It's an all-in-one computer now. The only downside is that the Monitor 3 doesn't have the ability to create files, so you'll need to create them on your own computer and then copy them across. So if you are actually creating code on here, then you need to transfer it via serial onto your computer, save it, and then save it onto the SD card or the PATA drive. So now I've got this disk here. I don't need to communicate with my computer anymore to load any programs up. I can now demo some of the programs that have been created using various add-ons. So the first add-on here is this 8x8 LED matrix. This is pretty much the same as the original 8x8 matrix, just in a more modern look and feel. There's also this board here, which was created by the creator of this computer, and which is fine, but it's actually not compatible yet with most of the code, because the weird way in terms of how 00 is represented on this is like the bottom left hand corner here, but this one here reads better actually, top right hand corner, and also the bits are reversed, so it's in sort of bit order here in terms of visually seeing the bits. With this one here, it's actually kind of in the reversed order, but that was the standard they did many years ago on the TEC. So both these boards can plug into the top socket up here, so I'll plug that one in. Alright, the board's plugged in, and because I've got the disk here, I can just load up some programs that will use the 8x8 matrix. So a really cool game that was created by Jim Robinson is called Magic Square. I've got to find it. There it is, Magic Square. So that's loaded, press go. And the idea is to get all these segments lit up. So there's sort of like these 9 segments, and all the ones around the outside, but not the one in the middle. By using the keypad here, they kind of swap different ones around. So if you practice hard enough, you can see the 9 key just is the middle key, and it will turn those segments on. And if I turn that off, the C key does the top left segments, top right segments, and middle segments. And just by playing with the combination, you get the square. It's a pretty cool game. So the last board I want to demonstrate is this graphical LCD screen here. Most users who have purchased this board have got this GLC board already. Monitor 3 has the ability to, or APIs or routines that you can easily control this GLCD screen by creating lines, circles, squares, shapes. And to know it's connected properly to the monitor, if I do a hard reset, so function and reset, I'll get this GLC banner here, which is like a little maze, TEC-1G. Thanks to James Elphick for creating that banner, and I know it's connected. So going to the disk here, I can just select some graphical LCD programs that are already created. So here's the graphical LCD programs, or the collection of 3 of them. I'll show 2 of them off. I've already shown these ones off before in previous videos. So if I go to 300, I've got this rotating 3D shapes, and there you go. You can rotate various 3D objects. Pretty cool, hey? So exit that. If I go to 200, I've got this maze generation program. Looks it's all done randomly. Pretty cool program. You can watch this for hours potentially. But one of the benefits of having the GLC screen and the keyboard together, it also has the ability to emulate a terminal. So there's a couple of programs that we've got that do utilize the keyboard and the GLC as a terminal, and I'll just show you them now. So if I exit that, go to function F, and if I load up Tiny Basic, So Tiny Basic was on the original ROM, but I ran out of space. I moved it off now. It's now on a separate file that you can put on your disk or your drive. T-Basic, load that up. That's loaded. And in order to run it via the terminal, you need to tell the TEC-1G that we are going to make it as a terminal. So you can do it either two ways. You can go to the main menu, go to settings, and go to toggle G LCD terminal, and you got a little cursor up there. That's been done now. Or you can do function 5. So function 5 toggles it on and off. Program's loaded. Press go. Okay, Tiny Basic, cracked by B Chia. And now I can use this keyboard here to create a basic program. So print, so shift, hello, TEC-1G, close brackets, and 20 go to 10. Oh, let's fix that up. 20 go to 10. So if I do a list, it'll list the program off me and I can run it. There you go. Hello, TEC-1G. Control C to exit, Control D to exit the program. And the next program I'd like to demonstrate is this program that was put together by Sean Sistra. It's an interactive fiction program using the Z engine, similar to what Zork was using, and he's adapted it to the terminal and the TEC-1G. So if I go to the start of the program and run it, and what we've got here is Adventureland. Interactive classic by Scott Adams. So for someone who enjoys interactive fiction or text adventure games, this is really awesome. I'm really excited to see this up and running. And using the keyboard, I can go, let's say, east. Oh, and there's a sleeping dragon. Oh no, let's see if we can kill the dragon. Yeah, violence isn't always the answer, you know. So Sean's currently working on porting Zork across to the TEC-1G, where he'll utilize the SD card to load and save data directly to the card. So it's going to be awesome. Looking forward to it. And to complement Monitor 3, there is a user guide. It's 92 pages worth of everything you need to know about the monitor. It goes into details about every aspect of the monitor. It talks about the memory map, all the function keys. It has some Tiny Basic examples, how to convert old TEC-1B magazine code to the new monitor, all the API calls that you can access to interact with the monitor and to assist with your programming. For instance, reading the joystick or the full matrix keyboard. It's got sections on the RTC, the Graphical LCD interface, the hard drive access, and a handful of type-in programs that you can type directly into the TEC and learn more about the monitor and the Z80 microprocessor. So do yourself a favor, get one of these TEC-1Gs. It's a really great way to learn the Z80 microprocessor and programming with all its add-on peripherals here as well. And if you want a complete version of the TEC-1G, you can also get custom printed cases for it. Here I've got one here, which is my TEC-1G I Love Z80 3D printed case. So I'd like to thank PCBWay for supporting this channel and for producing all these add-on boards, and the community out there who've been behind it and been creating new and amazing programs for the 1G. So on that note, I'll see you next time. From vintage vibes to modern vibes for nostalgia's sake. Ready Z80. Let's code and play with the Z80. CPU leading the way. Assembly language. Come and take a stand.